Well, I've been a resident of this state, or citizen of the state, for all of about 3 weeks, and a resident of the watershed for about that long as well. So I thought the best thing I could do today is to try to put the issue of nutrient management in a more global and national perspective, and some local perspective, but local stories from a different part of the country. We live in a remarkable time when humans are better nourished than at any time in our history, on average. And that's because we have a highly efficient agricultural system, efficient in the sense of producing a lot of food at a reasonable price, with very little labor, which frees the rest of us up to do other things. And if I had this opportunity to put a sign out in the middle of the field somewhere, I would add to this, well, first of all, the fact that we have this abundance of food has both good and bad aspects to it. In that while we are better nourished on average, there's also about 1 billion people who are undernourished on the planet, and about 1 billion people who are overnourished, which has health implications. And I think that's a metaphor for the issues that we have with nourishment of the soils or the agricultural system as well, in terms of having excess nutrients. But as I was saying, if I could put a sign out on the field, I'd say that what we really are after is to try to produce more food with low pollution. So if you could condense that down into the fewest possible syllables, it would be mo-fo, low-po. The problem we have is that nitrogen is an inherently leaky nutrient. We have to have it to produce food. All animals and plants require it. But it doesn't always go where we want it to go. So if we think of the nitrogen going into a production system, agricultural production system, as a pipe, we feed in fertilizers or manure or natural nitrogen fixation, and out the other end comes some fraction of it that we consume as crops or as animal products, relatively small fractions, and these are just rules of thumb, sort of averages. The problem is a great deal of it leaks out of the pipes through various holes into the atmosphere and into the groundwater and surface waters, creating unwanted consequences of hypoxia zones, of air pollution, of greenhouse gases, and I'm not going to go into the details of those. I assume most of you are aware of them. Globally, there's a very interesting trend that set of trends that you can see among various different countries. On the left axis, left graph here, I have nitrogen input on the x-axis on all of these, and here we have the harvested nitrogen. How much nitrogen is in the grain or animal product or whatever is being harvested. And a typical harvest curve, or response curve, fertilizer response curve, looks like this dashed black line. And China, over time, the green line is China, and each data point is a year of data. And from the 1960s to 2011, China has sort of followed that curve of a fertilizer response. They put on more fertilizer, they get more yield, until you reach a point of diminishing returns. In contrast, Kenya is way down here in the bottom left corner. They're using very low amounts of fertilizer and have very low yield and making only very modest progress. The United States initially followed the same curve as China after World War II, but we took a turn in which we've been making more harvestable product with about the same amount of fertilizer, or the red one is the United States, sorry, for about the same amount of fertilizer for the last decade or two. France, which is in blue, which is representative of much of Western Europe, has gone even further in that they've turned the corner and are now using less fertilizer without decreasing yield. So as a result, that means their efficiency has gone up. And so the second graph is nitrogen use efficiency. Here we are up here in Kenya with nitrogen use efficiency greater than 1. That's basically, efficiency is defined as the outputs over the inputs. that means they are mining soil nitrogen, taking more out of the soil than they're putting back in. Although that has started to improve somewhat, but they are still mining nitrogen. China had a decrease in their efficiency as they keep putting on more and more fertilizer. The US and France are sort of turning it around. Surplus uses these same data, but now input minus output is the surplus. Now some of this may stay on the farmer's field, but over time, most of it eventually leaks out to the environment. And so in Kenya, the surplus is negative. So they can afford to add a great deal more fertilizer with very little risk of significant loss to the environment. In China, they just seem to be going higher and higher and higher in terms of surplus, whereas the US and France have sort of turned it around. The idea here is that policy does make a difference. Now, there are other factors as well. And in this graph, I've tried to combine, yield with nitrogen use efficiency, and now these different zones of color are the amount of surplus. You can see China is just sort of going down to the lower right where you don't want to be, where yield is going up but efficiency is going down, and therefore the surplus going out to the environment is getting bigger and bigger. Whereas the US and France have sort of turned the corner and avoided getting overall worse surplus values. It's not the entire story. This one's Canada. Canada it produces more wheat on average than a lot of the other nations, and that has an inherently high nutrient use efficiency. This dotted line here is Brazil. That's a pretty interesting one, that they've going through agricultural development without the same sort of problems that China has had. But they have the advantage that they have a lot of soybeans, which has relatively high efficiency. So there's a combination of factors that explain these trends. Well, since there are certainly cases we've been able to improve nitrogen use efficiency, the question is, why haven't we made even more progress than we have already, if we already know a lot about how to do this? And so I convened a group of us convened a conference in which we tried to get participants in the room from not only the usual group of academics, but also from industry as well. So we had John Deere, we had Fertilizer Institute, the Fertilizer Institute sponsoring this, IPNI, the International Plant Nutrition Institute, and we had economists, sociologists, agronomists. And we asked them the question, what are not only the technical issues, but what are the economic and social impediments for increasing nitrogen use efficiency? Well, not surprisingly, nitrogen the fertilizer itself is a significant fraction of the farmer's cost. This is for Indiana, about a third. And yet it was agreed upon by everyone there that although the costs are high enough for many farmers to want to conserve nitrogen, they also agree that the economic risk of applying too little is very large. It may only be 1 in 5 years that they have the right weather conditions for that bumper crop, but it's very important for them to be able to capture that 1 in 5 opportunity and profit from it. And in the other years, if they apply a little bit extra, that's okay because it's a relatively cheap insurance policy in essence. This is one of the first studies I'm aware of where someone's done a cost curve for various options to mitigate nitrogen pollution in agriculture. This one happens to be for Iowa, for a particular watershed in Iowa. And of course, for different areas, you may get different cost functions. And here there's assumption that it would cost a lot to ban fall fertilizer application. That had to do with their assumptions about building more infrastructure to have fertilizers available. So this would vary by region, of course. the important point here is that we're able to put these numbers in perspective as to how much money is being spent or would be spent if these various options were applied, so that we can actually consider it in terms of about $8 per kilogram of nitrogen removed, or $42 per hectare. Compare that to the cost of $10 per kilogram nitrogen removed at the sewage treatment plant. A survey of where farmers got their information was presented, and here it's the values here on the top part of the bar that indicate the area, the source that had the strongest influence on the farmer. And as you can see, those that had the strongest influence, their sources of information were family, chemical dealers, and seed dealers. And I'm sorry that ag extension even falls below bankers and lawyers, and conservation staff is way down here at the bottom. So really we have to think of a new model that ag extension should be informing the private consultants from whom the farmers are getting their information, perhaps through certification programs as such. I'm going to skip over that in a second. I wanted to share with you some slides from Laura Moody from the Fertilizer Institute about a survey done of private crop consultants and conservation staff. What they found was that the industry is promoting this idea of 4 R's, putting the fertilizer on the right place, the right time, the right amount, the right rate. What they found is that the retailers, of course, have already learned this from the fertilizer companies. And so they have a great deal of knowledge about it. But those in the conservation districts, many of them had learned about it the first time from this survey. The retailers were not very well aware of some of the financial assistance that are available to farmers through the conservation programs. And in turn, the conservation district people often were not aware of what many of the retailers were trying to do. So there's a lot of room for improvement by these types of partnerships. If you look at what they were recommending, the private consultants were mostly recommending things like split applications, stabilizers, variable rate applications, whereas the conservation people were mostly suggesting buffer strips, conservation tillage, planting cover crops. The only thing they had in common was soil fertility tests. And of course, all of the above are probably useful, and so those partnerships would be important. A positive story from Nebraska, in that over time, crop yield has been going up, fertilizer application has stayed about the same. That means efficiency must have been going up. Back in the 80s, it was recognized they had a serious groundwater nitrogen problem, and so there was legislation passed, and they stratified the river by areas of severity of the problem. In the least severe areas, they had regulations banning fall application only on sandy soils, so less severe regulation. Where there was somewhat of a higher risk problem, they had, as you can read here, other regulations that were somewhat more severe, requiring annual soil and irrigation water testing and so on. Finally, at the highest level, even more regulation. And over time, we've seen that nitrate in groundwater has come down, nitrate in soils has come down, although it's still got a long ways to go to get down to 10 ppm, which is the EPA standard. A take-home lesson from this is that policies, regulations, incentives, whatever they are, carrot or stick, need to be tailored to the local conditions and administered by local authorities. One last point is that looking at a possibility of the way that we can provide farmers and local managers, even national accounting folks, a tool to look at improvement of nitrogen use efficiency is if we go back to this idea of looking inputs and outputs, where output is on the x-axis, surplus is on the y-axis. This is a hypothetical example of corn in the Midwest. If we think of this over time, the trajectory is, if we could plot this over time, if you can move to the lower right, the farmer wins and the environment wins. And these are data that are generally already available to farmers, already available to managers, and national accounting possibilities. So we've summarized much of this on a website and have a brochure about the consensus statement that came from this meeting, and I welcome you to take an opportunity to look at that. Thank you.